don't want to look down. Within my memories, I'm going back in time. My life is right in front of me while I'm trying to find mistakes or ways that drove me down. You will not break me out. When you describe it, it gives me a break, and it's like my body's light. When I take a second breath, I can feel it all coming back. Is that a weight of the world dragging me down here alone? No matter where you are, I'm dead now. Under pressure, without a way out. The problem is closer and closer again. I'm calling you now. Where is you at now? Where is you at now? After this, the life will not be the same. And if I survive, I keep only your name. There is a new life where the light shines. And I fight with my arms and with my hands. With my hope, with my faith, with my heart to reach up the world. I was screaming in the dark till I'm no longer ignored. All the facts of my life are knives falling from the star sky. They are cutting me, hurting. How can I stay alive? Is that a weight of the world dragging me down here alone? No matter where you are, I'm dead now. Under pressure, without a way out. The problem is closer and closer again. I'm calling you now. Where is you at now? Where is you at now?
Hi, everybody. Welcome back. Yesterday, we went through a lot of vocabulary with parts of waves. Hopefully, you can use those demonstrations to help you understand the parts of a wave. Today, I want to go over the different properties of wave, kind of retouching on that vocabulary just in the writing so we can see what's going on here. Hopefully, things are going well. Weather's starting to get nice outside, so hopefully you guys are getting outside and doing some fun stuff here. Only a couple more weeks or days or whatever it is until we're done doing this social distancing. So keep going on, keep plugging away. We'll get through it. Okay, try your best. Whatever you do now, you'll appreciate that in the future. All right. So today what we're going to talk about is properties of waves. How do we describe a wave and what determines the energy of the wave? The first thing we're going to talk about is amplitude, the amplitude of a wave. Now, you may have heard of someone talk about it, an amp, like an amp, to amplify something. To amplify something is to make it louder, to make the wave bigger. I'm going to go ahead and read this first part here. What is the amplitude of a wave? An earthquake in an ocean can make a transverse wave called a tsunami. The waves can get very tall as they reach the land. The amplitude of a transverse wave is related to the height of the wave. Amplitude is the maximum distance the particles of the wave vibrate away from their rest position. The rest position shown in the figure below is the location of the particles of the medium before the wave gets there. So when we take a look at amplitude, small waves would have a low amplitude, and big waves, giant waves, have high amplitude. So if you think about a sound wave, if you have a speaker or something and you have the sound on low and they're smaller waves, okay, if you turn it up, the waves get bigger, so it's louder. Let's take a look at the relationship between amplitude and energy. The taller the waves, the larger the amps or the amplitude. The shorter the waves, the smaller the amplitudes. It takes more energy to create a wave with a large amplitude, therefore it carries more energy. Small little waves, or it can make huge waves. The big waves were harder to make. It took more energy for me to move that. It made me move that wave more to create more energy. So that is the amplitude. Amplitude of the wave, the more energy I have, the higher the amplitude I will get. All right? The louder something is, the bigger the wave. The bigger the wave. Think of like the waves you go surfing with. The higher the wave, the more energy it has. The more, if you've ever been in the ocean, you've been knocked over by a wave, the bigger the waves, the more power it has. The more power it has. Talk about is wavelength. The vocabulary word wavelength, if you think back to the slinky and the wave was moving up and down, wavelength is the distance between any point on a wave. So if we take a look at a transverse wave, if we take a look from crest to crest, we have a wavelength. That's called a wavelength. If we look at a longitudinal wave, we can look at the compressions from compression to compression. That is a wavelength. The shorter the wavelength, so the faster the waves, the more energy there is. The longer the wavelength, you think they go long waves, the less energy there is. The next thing we're going to talk about is the frequency of a wave. Frequency is measured in hertz, kind of like the car, rental car, hertz. 1 hertz equals 1 wave per second. So every time a wave goes through, 1 wave per second would be 1 hertz. So if you take a look at these two waves, we measure waves from either from the crest or the trough. Here I'm measuring from crest to crest. This time right here represents 1 second. If I look to see how many crests go through in 1 second, I have 1 crest, 2 crests, 3 crests, 4 crests. So this wave up here would be 4 hertz. If I take a look down at the bottom one, I have 1, 2, 3, 4, 5, 6, 7. So we would have 7 hertz. Now, 7 hertz has more energy than 4 hertz. So you can see here that the more waves, if our amplitude is the same, if the height of our wave is the same, the more waves that go through gives us more energy. Okay? Now, when we start talking about sound waves, we'll see that when they have higher hertz, it's a higher pitched sound. When you have a lower hertz, it's a lower pitched sound.